Good morning. Hello, everybody. Hi, hi, hi. How are we? Hi, guys. Good morning, Caitlin. Good morning. So nice to have you guys here again. Hi. So how many of you guys are tired of the snow falling? I swear, like it just won't stop. It's just, even if it's just a little bit to make the roads gross or your car more gross, it's just crazy. Nabril. It was fun looking for all these jokes and stuff. It was, I was laughing a lot of them. Some weren't appropriate, but yeah, it was good. Hi, Luna. I sent you a message, Luna, so welcome to Science. I don't know if you got it. It'll show up probably at the bottom there that I sent you a little private message. So if you just want to look at that, it's a little late now, but it's okay. It's all good. Good. Oh, everyone's joining in. Here we go. Okay. Awesome. Yeah, thanks, Luna. So good. Anything fun to tell me from the weekend? We didn't have class yesterday. I'm used to having Monday class with you guys, so this is the first time doing it on a Tuesday. But how was the weekend? What did you guys end up doing? Anything super fun, exciting? What did I do? It seems like so long ago. I can't even remember what I did. What did we do? Oh, we had friends over. What did we do? I can't even remember my weekend. That's so crazy. I know, Jess. I was just talking about how I love that you're in Hawaii and you're still signing in. That's so cool. That's got to be beautiful over there. I can't even imagine. School and ate food. Eating food's a good thing. That's a good thing. Watch the Super Bowl. Oh, yeah, I did that. Oh, I was up at the hill all weekend. That's what I was doing. My friend has a cabin, gets a cabin up near Idabel Lake, so we were there all weekend, Friday, Saturday, Sunday. So got back in time to watch the Super Bowl, which was really good. Hi, Alyssa. She's here now. Good. Awesome. At the theater. Oh, you went to the theater. That's kind of fun. That's a neat thing. Yeah, so the Super Bowl was good. The commercials were good. Those Tide commercials killed me. I thought they were so funny. Every time one came on, all of a sudden, because there was a guy on the horse for the Old Spice commercials, and then all of a sudden he's like, I'm in a Tide commercial. I thought that was so awesome. Yeah, it was good. And the football game was good. It was one of the better ones, most yards in the game. It was really kind of neat to see all that. Let's see. Okay, good. Thanks, Luna. Okay. Excellent. So, just a reminder that on Friday is badminton. Okay, no problem. So, yes, so on Friday, this Friday and next Friday is badminton. So I went and watched a little bit. Belle was there. I saw Belle. She was whacking that birdie around everywhere. Yeah, so it's a fun thing to get involved in. It'd be nice to see a few more of you guys there. All right, so today's plan, we're going to look at molecular bonds. You do have a quiz today. Am I actually meaning you have the quiz next day too? You do not have a quiz next day. That should be a quiz today. You guys have to do a quiz today, sorry. We're going to play, there's a naming game for you guys to work on, practice worksheets, homework sheet, reflection, all that kind of stuff. Okay. Now, before I go on, one second. This is not, no, one second. Miss Mac opened up the wrong file. I just noticed. 2 seconds. Because I'm like, that's not right. That's not right. This is going to be the better one. That's the better one. Okay. You guys got a preview from another one. Okay, so this is the better one. There we go. Food bank today, and then Friday is that. This is better. There we go. So we're going to look at ionic compounds. You have a quiz today. There's going to be a little simulation that you guys get to work on, and then a couple practice sheets before you actually have to do one of the homework pages. So I'm trying to give you guys a chance to practice. I'll give you guys the answer key so you can see, go, am I getting this? Look at the answer key, and then go, oh, I got that wrong, and then look at what the answer is and go, okay, am I close enough? What am I doing? Can I understand? Do I have to ask for help? You know, that sort of thing. So, so yeah, so that's what I'm trying to do before you guys have to actually hand something in. So, all right. So before we get into that, I want to do a talk about your airplane lab and just bring up a couple of things that I saw was more than a couple people did this, and I want to make sure that we're all on the same page and understanding what I'm talking about with that, okay? So you don't necessarily have to take notes on this unless you're someone that's going to forget this, but if you want to take notes, you're more than welcome to do that. So for the most part, the labs were good. Most of you guys met expectations. A couple things that you need to be reminded of. So when you're doing any kind of graph, Magic Merle, can you just move that out of the way, the little bar there, so I can see what I'm writing here. When you guys are doing this, can you guys please make sure that you have 0 at the very corner of your graph? This should be 0, okay? This is always going to be 0. Now, when you're doing something and you need to draw the increments, that's what this kind of called, the increments going up the y-axis. You have to have a pattern. You can't just randomly throw numbers in. You have to be able to see a pattern. So I'm going to show you the wrong way of doing it. Let's say my numbers that I'm going to be putting on that y-axis is a 2, a 5, 11, a 13, and a 14. I can't just go 2, 5, 11, 13, and 14. I can't do that because there is no pattern to this. What has to happen is in between, what's going on there? Why is this pin up there? In between here, I'm going up by 2s. In between here, I went up by 3s. It has to be the same pattern. So whatever I start with, that has to be the pattern I continue with. So here would be a better one. I have to go up to 14. So you figure out how you're going to make it. This has to be a 0. And I can go up by 2s, I can go up by 4s. It doesn't matter what you go up by as long as it's a consistent pattern. So here I could go 4, 8, 12, 16 if I wanted to. I could go up by 3s, but it doesn't matter. I went up by 4 here, and between these two is another 4, and between these two is another 4. So that was one of the main things that I noticed on your guys' graph, was that you didn't have 0 at the bottom. So you didn't have the 0 here. Some of you guys started at a 10 or a 5 or a 2, and your increments were not a consistent pattern. So you have to have that consistent, okay? When you go Katie, when you go File, go to Save as a PDF. That's one of the options. Or you can go File, Save As, and then one of the little drop-down menus, it'll say a Word document. Drop-down menu will allow you to go to a PDF, okay? The other thing that I wanted to point out with this, and somebody, actually Paige, I think I just marked yours this morning and you actually did this, which is really cool. You have another option that you can do. Let's say my numbers, so I'm going to start at 0 on this guy. Let's say my numbers are all really, really large, but they're all around each other, okay? So I'm just going to delete these ones. And let's say my numbers are all 20, 21, 22, 23, and 24. Let's say those are my numbers. I don't want to start at 0 and go 5, 10, 15, 20, 25, because all my numbers are going to be crunched in between the 20 and 25. I don't want to go up by 2s. That's going to make my graph too big and all my data is on the top. So what you can actually do is put a little little sway in between the 0 and your first increment, the first number that's going to be on your y-axis. And what that tells the person looking at it is that there's a break in the bar graph, meaning that it's not going to be a pattern from 0 to the first one. There's a break. The pattern is actually going to start from that first number. So that is what you can also do. So if this technique here doesn't work because it just doesn't work with the numbers, it doesn't make your graph nice, or whatever the reason is, you can do something like this. And now I can go up by 1s, okay? And what that break is telling everybody, this break right here is saying it's not 0 to 20, 20 to 40, 40 to 60. That break is saying don't look at the pattern until you get to this first increment right here. When you get to that first increment, that's when the pattern starts, and that's going to be +1, and so on. Okay? So how is everybody with that? I want to make sure you guys understand how to do the graphing. I just got a couple other things just to mention, but is everyone okay there? Okay. Dean is approving. Yeah, that's awesome. Okay, good. Okay, so the other thing that I wanted to mention to you guys is I want to talk about the lab and your hypothesis. So despite having 2 sheets of paper that remind you how to do a hypothesis, some of you guys either ignored that or didn't understand it. So a hypothesis, you need to put if, then as your statement when you're writing a hypothesis. So if I throw 3 paper airplanes with different weights, then, okay, so I start, whoopsies, I start with the if and I do the then, okay, then the one with most weight will fly the farthest, okay? Something like that, okay? So your hypothesis has to have an if and then, and it needs to state what you think is going to happen, and it's only a one thing kind of answer. You don't say, well, maybe if it happens this way, then I kind of guess that it could go this way, but it could go this way. When you're making a hypothesis, you're being wrong is going to be what mostly happens in science, okay? When they make hypotheses, they're mostly wrong. Eventually they become get a right one, but then later on in life it changes anyways, right? So what you have to understand, it doesn't matter if you make a choice and you get it wrong. It's just the direction you think that it's going to go. You've done a little bit of research, some thought, whatever, and that's where you think your results are going to go towards. If it's wrong, that's fine. If you don't have a clue, you are guessing, you're supposed to not make it as much of a guess. That's the difference between a guess and hypothesis. But you need to be firm with what you think is going to happen, okay? So you don't just say, it's going to be this one or this one. It's like, the one with the most weight is going to go the furthest, period, done. And then at the end, you're like, I was right with my hypothesis, I was wrong with my hypothesis, here are my thoughts, here are the things I could do better next time, you know, all that kind of stuff. Is it a theory of what might happen? It's not a theory. A theory is totally different than a hypothesis. Hypothesis is just if you're doing an experiment. A theory has a whole bunch of factual information and tests, and it's just a massive amount of information that they're able to then form a theory. It is just basically kind of like a hypothesis is what you think is going to happen. Okay. Yeah. Okay, cool. So that's that. So make sure you guys are doing that. And the other thing is, actually, I'm going to go back to here. Down on the bottom here is usually your independent variable. Okay, that's usually the thing that you're changing. So here it could be the trials, it could be the weight added, whatever. And this is usually your dependent variable. So this is usually your results. Okay, so this could be how much money, or it could be how long it took something, or how far it went. So that's usually where that stuff goes. A lot of you guys didn't include in your lab your variables, so that's something that you should always just add in. Let the person know what you controlled. So even when we watched the Mythbusters, they did talk about what they controlled and what they had to take into consideration. So that's stuff that you should be adding in there. Okay, all right, so any questions on that? Perfect, thanks, Bill. That's good. Okay. All right. Are we good there? 1 second, I forgot I wanted to start recording that. Okay, good. All right, so some of you guys just looking at the hand-ins, there is a couple of you guys that stole me the Mythbuster. So Emily, Alyssa, and Danica. Danica's not in here right now, is she? No. And then the airplane lab, I have Emily, Alyssa, Lindsay, Paige, Slade, Cassie H, Belle, you fixed it, Katie T, you just need to fix yours, and then I can mark it, Alexis and Danica. So, okay. All right, so that's the only thing I want to talk about, those labs. And then today I'm going to mark the work that's due today. There was just a couple of those little worksheets too. Thanks, Sam. Thanks, Katie. And a couple of those worksheets for you guys to finish for today. Okay, so let's go back to this one. And hopefully you guys had a chance. I'm going to try to open it up as quickly as possible for you guys to print off the notes before each class, because it really is going to help. So I opened these up, I think, on Friday. So you guys had the weekend, you had Friday, you had Monday, and this morning to try to print off the notes ahead of time. So just try to do that for me. That would be fantastic. Okay, so today you're going to learn about kind of how to make chemical formulas, how these formulas, the compositions of them, the names of them, and then be able to describe some of the properties of them. Okay, so that is what the plan is for. So we're going to do a little warm up. All right, why do we name objects, peoples, pets, elements, etc.? So just typing in Blackboard there, tell me, why do we name stuff like that? What's the purpose of us naming those? What are some of your thoughts on that? Why do we name people? Why do we name elements and objects and things? And why do we do that? To show they have a meaning, to recognize them, so we can differentiate them. Some other thoughts. To separate them, to show their importance, because otherwise no one understands what we're talking about. For fun. Good. Good answers, guys. I love the diversity of the answers. They're all kind of different. How would I call my dog? Exactly, right? So that's really cool. You guys came up with some really great reasons to distinguish them, to name things. And so if you notice, elements is in there, and that's why there's names for things, and that's why things are categorized, so that we can distinguish them and know what we're talking about and be having the same language and know what we're saying. So if I called that a cat and someone else called that a dog and we're talking, we don't know we're talking about the same thing, right? So that's why it's really good that we have something that we all understand is what that means and what its name is and all that fun stuff, okay? Do all names stay the same? Does your names always stay the same? So if there's a name of something, does it ever change? So if we had a name for something, does it ever change? See if you can think of an example. Yeah, some names change. What are some examples that might have changed? Do a little bit of thinking there. What would be good, right? Your last name can change, or you can change your first name. I know a few people that have changed their first names, right? Yeah, so that's something that can change. Yeah, exactly. What else, any other names of anything else changes? Yeah, so that was right. So he named it Eka Aluminum, and then he found out what the real name of it was. I don't know if he was naming it necessarily, but he was saying it's going to be like aluminum, but it's going to sit right in here, right? Your pet, you can, if you adopt it, you can change its name. Exactly, nicknames, perfect. So this is sort of leading into this part of the chemistry stuff, is that these elements have names, there have been theories involved, all that kind of stuff, and things do change and evolve as knowledge happens. So, you know, the term is don't be married to it, meaning don't say this is the only thing that is, it's the only name there is, this is the only way it's going to be, because a lot of things change as people learn and discover new stuff, right? Just like scientists long ago, this is what they thought, and then as technology got better, they were able to disprove that or show them different things, right? Just like Dalton, when he was talking about atoms, he says they can't be separated. Well, they can, but back then they didn't have the technology to be able to separate atoms. Now they can with fission and fusion and stuff, right? So it's just, like I said, don't be married to an idea, because things do change, right? Yeah, I know my cat has a lot of nicknames too. She gets called something different every time. She knows we're talking about her, which is good. So, all right. So we're going to start looking at ions. Okay. So last day we looked at just looking at the elements, and then we talked briefly about ions. And ions is when they're have a charge to them, and they're trying to like make bonds and all that kind of stuff. Okay, so this is your notes. So we're not going to start on this page necessarily. It will come up with the notes from there. So ions. So just a reminder, the noble gases are very stable, and they're on the far, if I'm looking at the table, the far right-hand side of the table, okay, on the periodic table. This demonstrates that atoms are more stable when they have a full octet, which is their valence shell, the very outside shell, it is very stable when they have a full one, meaning there's 8 electrons in there. Sometimes they're in the shell that there's 18, so that's a full one if there's 18 in there. So whatever their last shell is, it's full of electrons to the max that can be accepted in that shell, okay? Atoms will tend to gain or lose electrons to try to become that. They want to be stable, so they're always looking for a way to be stable. So if they can give one away and give it to somebody else, share it, or join up with one to be stable, they will. If they can get one from somebody or 2, they will do that. Yeah, you are, yeah, these are notes, but no, we're not at the notes quite yet. This is just a review from last day, okay? Atoms that have gained or lost an electron is an ion. Okay, so that is the difference between an atom and an ion, and one of your homework sheets was just to kind of distinguish that a little bit. They have some kind of charge because they've either gained something or they've lost something. Okay, so that is where we're going to be focusing on today, is looking at the ions. All right. So just a little humor. So this little guy, you can't see him. Oh, which way do I go? This way. There we go. So he wants to join the car, but they're like, no, we're full, you can't come in, because they're a full octet. Funny. All right, so now the notes are going to start here, guys. So you can start using your notes for this. So this is another little joke. I lost an electron. Are you positive? Because if you lost an electron, he's probably positive. Yeah. There's going to be a lot of cheesy jokes, trust me. I was looking for something all the time. Okay. So we're going to look at now taking atoms and joining them together and creating an ionic bond is what we're going to start looking at. So we have metals. So metals are usually the donors of the electron. So if you look at the periodic table, all those ones that are metals are going to be the ones that usually give an electron. That's typically how it goes. Okay. They donate their valence electrons to become a positive ion, which is a cation. Okay, so a cation is a positive ion. That's another name for that. Okay, so then we have the nonmetals, and these are usually the ones that get the electron. So the metal gives an electron, and the nonmetal, which is the right-hand side of the table, there's not a ton of them. The right-hand side of the table, they're the ones that want to take and receive the electrons. So that's usually how the give and take goes, all right? They accept them and they become an anion, okay? So they become an anion. So negative, anion, positive is cation, okay? A happy atom, when they have a full outer shell, and there's a happy one because he has a full outer shell, okay? So that's what their goal is, to try to be happy, to become a full octet on the valence shell, and they become kind of like a stable atom. It's their goal. All right, good. Okay, so more humor. Cations are positive. You guys get it? Because they're positive ions. You guys are laughing at my jokes. They're really funny. I found them and I laughed. I laughed a lot. I thought they were cute. Yeah. All right. So this is just a periodic table kind of separating the metals and the nonmetals for you. So the blue are the metals, right? So these guys are the cations. These are the ones that usually give an electron from their outer shell, and then the yellow are the nonmetals, and they usually accept an electron, and all of them are trying to become stable. So that very last line is noble gases, those where helium is and neon and argon and stuff. They're trying to do that. The oppositely charged ions are attracted to each other by a force called we're not there yet. All right. So, ionic bonding. So just an image of showing that we have an atom that has one electron, and they join up together, ionic bond. So the opposite charge ions are attracted to each other by a force called an ionic bond. Okay, so the one on the left here, actually, both of them, if you look at them, they're not stable, because this one, if they only have one shell, in this case, it's that first shell, so there's supposed to be 2 electrons in there. They're not stable. So they want to figure out how to be stable. So guess what? If he gives up one, this is probably the metal gives an electron over to this guy. He has none. Okay, so he's kind of technically stable now. And this one has 2, which means that shell is full because it's the first shell and it has 2 in there. So he's stable now, so they're really happy about that. So their ability to give and take electrons have allowed them to be a little bit more stable than what they were before. So that's an ionic bond. Okay, good. And this is just another example of ionic bonding. So we have a sodium atom, and if you notice in its valence shell, it has 1 electron and it's not stable. So if it gets rid of an electron, it actually has nothing in here. So now this inner one here, the second shell, becomes its outer shell and it's now stable. Over here, looking at chlorine, it is missing 1. It has 7, but it wants 1 more to be stable. So that's what happens here. So sodium gives the 1 electron over to chlorine, and when it does that, it now has only 2 shells. This one has an outer shell that's full, and it becomes sodium chloride, and I'll explain to you how we name these. That'll be the next little bit we're going to do. So that's just a visual. So how are we doing with the giving, taking, cation, anion, sharing, all that kind of stuff? We okay? Good, good. Okay, so now we're going to look at naming them. So first of all, so ionic bonds are formed between cations and anions. So just a little review here. Generally, it's a metal with a nonmetal. That's typically how they are. So for example, lithium is a metal, oxygen is a nonmetal, and they form an ionic bond Li2O. Okay, so that would be their chemical formula. So here's another example. So oxygen needed 2. It needed 2 electrons in order to be full. Because actually, if you look on the periodic table, oxygen is number 8. Okay, so it has 2 in the first ring and 6 in the outer ring, and it needs 8 there. So it's short 2 electrons. So it's looking for 2 electrons to make it stable. Well, lithium is 3 on the periodic table. It has 2 in the first ring, and then it has 1 in the outer, so it's not stable. It wants to get rid of that 1. So it needs 2, oxygen needs 2 lithium atoms to join with it so that everybody is all happy. So if we brought 1 lithium ion in, that gives oxygen 7 on the outside. Lithium's happy because he's got rid of his electron. And then this other lithium joins in, gives oxygen now 8 electrons in its outer shell, and lithium's happy because it's got rid of that extra electron. So that is why it's L2, because there's 2 lithium atoms and 1 oxygen, and they're as stable as they can be with that one. Okay? All right. I think I missed like half the page already. No, we're only halfway through, guys. We're only good. We've only done that first little chunky there. We haven't done the properties yet. All right, so what I want you guys to do is go to the Moodle site, and there is a little short clip, about 1:10, that I want you to just go, it's longer, but I only want you to go up to 1:10. The rest of it is something we haven't learned yet, so I don't want you watching it, and we're going to return in 1:30. So I'm just giving you guys just enough time to do that. So go now. We're going to start the timer in about 10 seconds and go and watch the clip. Okay, it's on the Moodle site. All right. Okay, that's okay. You can watch that a little bit later, Em. All right, so just a little video of kind of visually seeing with better graphics than what I can do how atoms bond together, okay? So now this is the next part of the notes. So properties of ionic compounds. So most ionic compounds have these properties, so things that can distinguish them. So properties about me technically would be blonde hair and then my height and color of my eyes and, you know, fingers, lengths, whatever. All those things are properties about me. So same thing with this. We're going to look at ionic compound properties. So they usually have high melting points. So when these guys bond together, it takes a lot of heat for them to actually get to melting. Okay, are hard and brittle. So if you were to try to smash it, it would smash up into little pieces, but they're very hard. Soluble in water, so if you put them into water, they do eventually dissolve more so than some of the other compounds that join together. They form electrolytes, which is what allows for the conductivity of electricity when they dissolve in water. So that's a really cool thing, that they become a little bit more conducers of electricity when they're in water. So that's kind of a neat thing. Okay, sorry, I'll just leave that there for a second, because you guys have to write those down. Sorry, Luna, I just saw the second part of your message. So, yep, that sounds good to me. Thank you. Okay. So we're just going to look at some of the information that they gave here and just look at it a little more closely and see what they're talking about. Anyone need just a few more seconds here? Oh. Okay. Okay. So we're going to look at the crystal lattice structure. So this is sodium in the green and the purple there. That's sodium and chloride put together. And when they form an ionic bond, they actually form into that shape. And that's usually, they call it a crystalline structure is what they really call it. And when they form that way, we have a timer going. When they form that way, that's when they're more brittle and more conducive to conducting electricity. So it shows sort of the bottom picture there. This guy shows what happens. So because they're structured this way, they're easier to be split apart. So that's why they're hard, but they can be broken. They are quite brittle that way. Okay. All right. And so ionic compounds in water, so when they are dissolved, they separate into their into ions. Okay, so they're all in one group kind of thing, and then when you put them to water, they start separating into their ions, and then that allows them so that they can be moved and adjusted in order to conduct electricity. Okay, so they can move around in order to do that. When they're stuck, a lot of things that when they're stuck like that, they can't conduct electricity because they can't move in order to allow that to happen. So yeah, so that is your first page of notes, guys. Okay. So now what we're going to do, and this is just a little bit of background information just to understand what we're looking at. So now what we're going to do is look at how do we actually start naming these. So I showed you that that there was a sodium and a chlorine one. We put them together, sodium chloride, right? So you're like, I don't understand. Why did you change the name? And lithium 2 oxygen, I don't understand, oxide. So we're just going to start looking at what that actually means now. So we're going to look at naming the ionic compounds. So many ionic compounds are made up of metal and nonmetal. So you guys learned that already. So those are the first two blanks on that second page there. So you guys know they're made of metal and nonmetal. The metal always comes first when you're naming them, and then the nonmetal comes second. So even if we mix them around, look on the periodic table, which one's the metal, that one comes first with the name of it, and then the nonmetal comes second, okay? And then what you do when it's an ionic bond with a metal and a nonmetal, the nonmetal, you change the last little bit of its name to ide, I-D-E. So that was chlorine became chloride, oxygen becomes oxide, okay? So you change the ending of its name, and that's a proof that it is an ionic bond, okay? So that's when you take the metal and nonmetal, when they join together, sharing electrons, or sorry, giving and taking electrons, then their last word turns into ide. Yeah, fluorine comes fluoride, yes. So example here, aluminum and oxygen, they join together and it becomes aluminum oxide, okay? So you don't change anything else with aluminum, you leave the metal, you just change the nonmetal's last name. And then lithium chlorine is lithium chloride, okay? So that's just a couple examples of doing that. Okay? So that is the two examples on your sheet. You guys can be writing those in. Okay. Okay. So I'm going to show you guys a couple other ones. Yeah, and you don't capitalize, sorry. That's on your sheet as well. So here's a couple other examples. So these are the nonmetals. So they're on the right side of the periodic table. And this is what their names would be. So hydrogen, hydride, fluorine becomes fluoride, chlorine becomes chloride, bromine becomes bromide. You guys get the idea, right? So this is what, this is just a handy thing to look at, and if you're confused how to write it or how to spell it, you guys can just come back to the video, find this spot, and it's right there. It's nothing you guys needed to write in your notes or anything, but just shows how you just change the last few letters to I-D-E. Yes, Caitlin, Kate lied. Kate, oh, you lied, you're a liar. So what I want you guys to do, you can do this kind of at the bottom. So on your page, there's a box on page 2, then there's a little bottom spot. You guys can do a little bit of practice down there if you want. What I want you to do is, or you can just do it in your head and make sure you got this. Oh no, let's do this together. I'm going to change this. Let's do this together. So what would chlorine turn into? What would that one be? What does that turn into? Chloride. Perfect. What does fluorine turn into? Fluoride. Bromine turns into bromide. Oxygen turns into oxide. Sulfur. Ooh. Sulfide. Yes, good job. Nitrogen. Oops, I showed it already. Ooh, that's wrong. Nitride. It's nitrides. It's, some of them sound really weird, but yeah. And phosphorus. Phosphide. Good. So you guys are just going to have to get used to just remembering that that last non-metal word changes to IED. I know, phosphide. Phosphide. So there are 2 on your sheets. I'm going to give you guys 1 minute. There are 2 in your sheets. One of them is already written in its formula. So I want you to look on your periodic table, which you always should have printed out in front of you because we're going to be always referring back and forth to it. We're just on right kind of in the top of the second page, kind of a quarter of the way down. Yeah. So it says example, it says MgCl2. What I want you guys to do is write down what the name of that would be. So you'll have to know what Mg stands for, you have to know what Cl stands for, and then write it with the proper format with the IED and the nonmetal. And then the other one has actually named it. So it says it's lithium is the metal, nitrogen is the nonmetal, and now I want you to change the wording. Okay, so you guys got 1 minute to do that. Go ahead. Perfect. I think Alexis, I think I helped her. I think she knew where we were. I think that was an old question. Not sure. Sorry, Alexis. I thought I answered that. I'm not sure. Okay, so what did we get there? So what is the name of the first one? MgCl2. What would be the name of that one? Someone wants to type that in. What did you guys get for that one? So MgCl2. I'm just using that language instead of saying it. It's okay, you can catch up, Jocelyn. It'll be recorded. Yes, magnesium chloride. Good work, guys. And the other one, we have lithium and we have nitrogen. So what would those two be if they get combined together? What would that be? Yes, lithium nitride. Good job, guys. Perfect. So we're going to do these together. So the first one, so this is just a reminder. You take the first name, the positive ion is a metal, and that's the first one that appears in the name. And then you look at the second one, it's a non-metal. So we have sodium chloride. We've done that one already. What would the next one be? Some of you guys that have your periodic table handy, what would CaCl2 be? What would that one be if we were to name that one? Calcium chloride, question mark. Any other thoughts or anyone agree? Okay, good. KDP, oh, this isn't on, no. I thought you typed some kind of weird word. That's so funny. No, we're just doing it as a practice. Yes, calcium chloride, good job. And the other one we had on the other sheet, which was lithium oxide, which is good. Perfect. Okay, so now what is going to happen is the next slide is going to be where it says writing the chemical formula. We're going to write a few notes in there. Then the box part is where you're going to, at the same time, write down how to write the chemical formula from the names, okay? So you're doing two things now. Now you're writing in the spaces that are missing, the blank spots, and then you're also kind of taking notes on how to write a chemical formula, okay? So do you guys understand that? So you're filling in the gaps where it says 1, 2, 3, and 4, and then the box right below it at the bottom of page 2, you're going to actually take notes of how to write the chemical formula, okay? All right. So now we've learned how to name them. Now we've got to go from, okay, if it's named, how do I actually write it, okay? So step 1, so you guys are going to be filling in the blanks and also writing Mg and Cl in the box at the bottom, okay? Good? So write the symbol of the element. So find the metal and write the symbol, okay? So the first one is magnesium, so it's Mg, and then the second one is chlorine, and you write, or chloride, so or whatever, and you write Cl, okay? So now we're taking the words and we're going to be writing that in. No, we're on the second page. We're at the bottom of the second page, Christiana. You're missing a whole bunch of stuff there. Yeah. Okay. So magnesium chloride, chlorine is the words, and now we're going to write the formula. So we write Mg and Cl. So the left side is always the metal, right side's always a non-metal, okay? So step 2, we're going to add the ionic charge of each of the ion, okay? So number 2 is you're adding on the charge. Now in the box, what I want you to do is below the Mg and where the Cl is, I want you to write what the charge is. How you write it is up to you. You can write it as a little tiny number on the upper part of the Mg. You can write it next to it, below. It doesn't matter, but you're just going to write down the charge. And how you figure out the charge is using my little cheat sheet graph that I gave you guys. So it's this one here, and if you look, magnesium, where did my mouse go? Oh, sorry, thank you. If you look, Mg right here is a +2 charge. What that means is what? What does that +2 mean? What is that telling us about the electrons or its shell, or what is that telling us? Has 2 extra what? 2 extra what? Yeah, excellent. It has 2 extra electrons in its shell. So whatever its last shell is, it has 2 of them. It doesn't need them, okay? And then if we do chlorine, which is right there, number 17, it is under the -1, which means it is short 1, okay? So what we need to do is try to make magnesium and chlorine do an ionic bond together, metal and non-metal, so that they can become stable. So we're looking at this going, he has 2 to give, he only needs 1. So we have a little bit of an issue we got to figure out. So I'm going to show you 2 ways of how to solve this. Okay, so step number 3, we need to determine the number of ions required to bring it to 0, because that's our goal. A stable means that they have exactly what they need. So in order for this to work, we have to kind of almost find like a common denominator. You know how you guys had to do that? It's almost the same idea. So if I have magnesium has 2 charge, and this has -1, the number that they have in common would be 2. I can get +2 to stay 2 by timesing by 1, and I can get the 1 to turn into 2 by timesing by 2. So what that is saying, that's how many how many atoms I am going to need of each one of these to make them join together properly. So it says I need 1 magnesium, and I'm going to need 2 of these because he has 2 extra things. So I'm going to need 2 of these guys that he can give 1 to this one and 1 to this one. Okay? So you guys should have that written down as your next step in the box. Okay? So your first step in the box was you wrote Mg and Cl, then you wrote down the charge, +2 and -1, and then now you're showing how that we're going to make these guys match to 0. So that's where that's where the 2 is going to come from. I'm going to show you an easier way of doing it. This is the longer way, but I want you to understand this, and then I'm going to show you guys just another way of doing it. Okay, so that's step number 3, is trying to make it figure out how can we make them balance out together. Okay, so step number 4 is now you're going to take that red piece, obviously your notes if they're not in red, but I'm showing you in red on here. You're going to take those and you're going to put them as a subscript, which means those little tiny numbers at the bottom. You're going to make it a subscript of below the atom, and that's showing how many of those atoms you need. So here we said we only needed 1 magnesium, so we've put the 1 as a subscript to the magnesium Mg. Here, for it to balance out to become 0, we have to have 2 of them. So we're going to put a 2 below the chlorine chloride, and that is now the chemical formula for magnesium chloride. Okay? Now normally, so look at the note, it says normally you do not write the subscript 1. So the technical answer is MgCl2. So that you can write in the box as well. So what I would suggest doing is writing this so you can see that there was a 1 there, and then write this and maybe circle it as the final answer, because we don't put the subscript 1. If there's a 1 there, it's just like we're lazy in math, we're lazy in science too, because this is sort of mathy. We don't put the 1 there, we just put the 2. And it comes magnesium chloride is the name of that one. Okay, because you change the nonmetal to an IDE. Okay, so how is that? So that's just a little way, and I'm not going to stress about this one too much, because I'm going to show you another way that's super easier and it's fun to say. Yeah. Crisscross. We're going to do crisscross method. Okay, so this one I don't have anything for you guys to write in, but I want you just to do the box part. So with this one, I want you to write down magnesium 2+. So that was my example of saying, putting it as in the top there. So that's showing the charge of magnesium, and this is showing, they don't show the -1, they just put negative, that's showing it's -1. So write that down in the box. We're on top of page 3 where it says crisscross method. It's going to be crisscross applesauce, okay? And what we're going to do is, instead of worrying about, okay, this needs 1 of these and this needs 2 of them and do they equal 0, we don't have to worry about that because we're going to do the crisscross applesauce. So all it means is you take the charge of the metal, put it down below the nonmetal, and then you take the nonmetal charge and put it below the metal. Okay, so there I took the 2, put it below the Cl, crisscross, Cl goes below the magnesium. So that's crisscross applesauce. So you guys can draw that on your sheet and then show the final answer, MgCl2. Okay, so I'm just going to show it all over again here. So what we did here, we have the metal on the left, magnesium with a positive 2 charge. We have neon, this is just another one. We have nitrogen with is 3 to the negative. You might, Christiana. Okay, we're on the top of page 3, crisscross method. Okay, so we have the metal, which is magnesium, and we have nitrogen. And we have, doing the crisscross method, all you do is crisscross them. The 2 goes over there, the 3 goes over there, and then, whoops, and then you get your final answer, magnesium 3, nitrogen 2. So in order for those 2 to join together to become as stable as possible, then what you have to do is have 3 nitrogen, and, or sorry, 3 magnesium and 2 nitrogen, and they join together to make an ionic bond, and they're happy. Yeah. Sorry, can you go back one slide? Oh, that one? Yeah, perfect. Okay, so that is just understanding. I showed you 2 ways. The crisscross applesauce is the easier way, because once you know the charges, you just cross them over, and that's how it goes. Okay. Oopsies, I went backwards. Like that. Okay. So what I'm going to get you guys to do, I'm going to give you guys 3 minutes to do this. You're going to practice this, and I'm going to give you guys some questions. They're not on your worksheet, so you can find, you have some room on the bottom of the back of the page. You can do it on a separate piece of paper, whatever you want to do. I'm going to give you guys some questions. You don't have to write the questions out if you don't want to, whatever, you can just answer them. What I've done is almost like this. I'm giving you, actually I'll show you. I've given you the atom. I've told you its charge. I've given you the metal and the non-metal. What I want you to do is do the crisscross applesauce and write down what its actual name would be when you did the crisscross applesauce. So I'm going to give you guys 3 minutes to do that. Notice at the bottom it says reduce to the lowest factor. So if I have a 3 and a 3 as my 2 subscripts, they reduce and they become 1s, and I have no numbers there. So hopefully you guys are able to do that without me showing you, and when we get to it, I'll show you anyway. So, okay? So 3 minutes. See you guys in a sec. Okay, so we're going to look at these, and there's only, I think, 2 of them you have to worry about the reducing on this one. So I'm not going to make you type because it's just going to be a little bit harder to type, but I'm just going to go over the answers here. So crisscross applesauce, the 1 from bromine goes underneath the magnesium, but we don't write it, and the 2 from magnesium goes underneath the bromide, so it becomes magnesium bromide, basically. We have lithium 3, and the P is a 1 because they cross. Calcium and oxygen. So this is the one where you have to reduce because they're both 2s, and the 2s go crisscross applesauce. But because they're both 2s, we can reduce, divide both by 2, and it becomes 1 and 1, and we don't write the 1. Do you always change the ion to a positive when you cross it? We didn't change anything from positive or negative. There's no positive or negative showing in any of the answers. They're just the numbers. Is that what you're asking me, Belle? So calcium, because it has 2 extra electrons to give, so it's +2. And oxygen is 2 short, so it's 2 negative. So that's what those mean. But when we do the crisscross applesauce, there's no signs involved. You just cross them over. I hope I answered your question there. Okay. Aluminum and chlorine crisscross. The 1 goes over underneath aluminum, and the 3 goes under chlorine. Okay. Potassium and sulfide, so the 1 goes below the S, 2 goes below the K. And if you watched how they got their names, you understand like some of the stuff why potassium is a K, right? You'd think it'd be like PO, like poo, but it's not. And here's the last one that you had to do reduce. So when we crisscross applesauce, we got a 2 and a 4, so we reduce both by 2. So when we divide by 2, the 2 becomes a 1, so it's C to the 1. Subscript 1, and the oxygen becomes a 2 instead of a 4. Okay? So yeah, how are we doing? Give me check marks or X's. X's means you're still like totally confused. Check marks mean I got some wrong, I'm doing okay, I'm doing great, I understand my mistakes. How are we doing? Good. Yeah. Good, good. Okay. So now we're just going to add a little bit to this now. And so now we're on the multivalent on page 3. It says multivalent, I always say it differently each time I say it. So it's just going to be anything I want to say. So what this means is that some of the atoms have some possibilities. Okay. So throwing a little a wrench into this. So for example, iron, which is Fe, it could be a +2 or a +3. What that means is that it could have 2 extra ions to give off, or electrons, sorry, to give off, or it could have 3 to give off. So what I want you to do in that box where it says multivalence ions, there's a box, just write down some of these examples. If you want, you can write all these down. And I'm just going to talk through while you guys are writing. These are ions that could give 2 or more possibilities away. And we're going to look at how we deal with these guys that aren't just as simple as aluminum having +3 or whatever it was. What is aluminum? Oh, it is +3. It's not as simple as that. If iron's there, it could be giving off 2 or it could be giving off 3. Okay, so just write down some of those examples there. Okay, good, good. Okay. And then we're just going to look at understanding how to write multivalence, which is going to be the next part on page 3. It's called writing formulas. Okay, so we're going to write the chemical name for copper 2 bromide. So this is its ionic name, and it says bromide, which means that's the nonmetal, copper is the metal, and copper is one that has more than one number of ions or electrons it can give off. Okay, so this is indicating that in this example it's giving off, it's like a 2+, it's giving off 2, so it's copper 2 bromide. So what we're going to do is learn how to write this when we have the words for it. Okay, so copper is either, it could be a +1, so it could give off 1 electron, or 2, but because it says a 2, it's copper 2+. So bromide ion has a charge of -1. Okay, so in total, there needs to be 2, this is doing it the old-fashioned way, this is not the crisscross applesauce, has two, it needs to have two of its ions in order to match up with that copper, because copper is 2, bromide is 1, so it's going to need 2 of them. So it's going to be CuBr2, okay? Or you can do the crisscross applesauce method, and C is +2, Br is -1. You crisscross them and do it that, okay? We're on the page 3, yeah. All right, so that's just showing what to do with that one, okay? And question number 3, so where it says writing the formulas, it's 1, 2, and 3. Question number 3, how do we write multivalent ions? We write using what? It's a 2-word thing. R is the first word and N is the second. What would you guys call? You're funny. You're so funny. What would this be? What do we call these? If I put an IV there or an III, what are all those called when we do that? Roman numerals. Good. So question number 3 is we write using Roman numerals when they're multivalent, okay? So that's how we show copper 2. There's other ones that are 4, so you write an I and a V. So we use Roman numerals to show what number of electron that we're using, what charge we're using for it. They're highlighted in yellow, guys. So number 1 is charge. Number 2 is crisscross applesauce. Crisscross applesauce. Okay. So, chemical names, crisscross rule. So we have, this is one of the examples you guys are writing down on your sheet of paper. So we have iron 3 oxide. Okay, so that's the words we're giving. So this is how we figure this out. You should be writing this down on your paper as well. And we have iron 2 oxide. Iron 2 oxide. So what I want you guys to do is I want you to try and figure out how you would write the actual chemical, the letters of this formula. So we have the words, and now I want you to write it down. So I'm going to give you guys, you're going to have to use your periodic table maybe to look at the charge for oxygen and stuff. I would recommend doing the crisscross applesauce rule. Write the charges down, same as we were doing before, and then it tells you what iron is, and then crisscross applesauce. So I'm going to give you guys 2 minutes to do that, okay? Okay, so hopefully that was good. So iron 3 oxide, so what the iron 3 means is that it has a charge of +3. Oxygen, if you looked, is a -2 because it's 8 and it's missing 2 in the outer ring. So crisscross applesauce, and we get Fe2 from the oxygen and oxygen 3 from the iron. And the iron 2, so it's the same thing except we're using one of the different charges for iron, so it's a 2 this time. So because it's a 2, both are 2, both have 2's on the bottom when we crisscross, but we have to reduce. So divide both by 2 and we get 1, so that's why it's FeO. So that's the difference why it's really important to understand that there are some that have different charges, and those different charges actually affect the naming of them, and it actually affects what chemical it is. So think about it, carbon monoxide and carbon dioxide, those are 2 different things, right? So having however many atoms or electrons are shared and all that stuff does change the composition and actually what the ion is, a molecule is, yeah, that kind of stuff, okay? All right, so then there was 2 in your notes that here. So we have iron 2 phosphide, so it's telling me that we're going to use iron and we're going to use the 2 charge of it. What is the charge for phosphide? What is the charge for phosphide if someone has that handy for them? What is the charge? Phosphide. I know you guys are looking on your periodic table looking. So I'm not going to ever make you guys memorize the periodic table, but it's just like multiplication, the tables. If you know what 5 times 4 is, it's easier to do that than try to find it on the table. And same thing on here, if you know what they are, it's easier to remember that. Good. So yes, it has a -3 charge. So when we do this, we have iron is to a +2, phosphide is a -3, crisscross applesauce. We get Fe3P2. Okay? So you guys write that down and make sure that you are writing this stage. You should be writing the charges down so that you know where you're getting your information from. More you write it down, the more you might remember what it is. Just like I didn't go out of my way to memorize that oxygen is -2, but talking to you guys enough as it is, I now have it in my head, right? So a lot of times that'll happen. And then now we're looking at tin, and this is a new element that we haven't seen yet. Tin is also one of them, one of the multivalent ones. And so tin in this case, they're saying it's a 2. Sulfur, sulfide, is a 2 as well. So because they're both 2's, they reduce down to SNS. Snus, snus. Okay? How are we doing with that? So nothing too big. It's just that you're looking at some of these charges that have multiple, or atoms that have multiple charges. Okay? So then the next part is, how do we know which one we're using when we name them? Okay, so if I'm talking about iron, how do I know if I'm going to use the +2 or the +3? Or, for example, lead, am I going to use the 4 or the 2? How do I know which? Yeah, so remember also using Roman numerals. So what we're going to do is look at how we figure out which one they use when we're going the other way. This is easy. This is easy because they're telling us. They told us it's iron 2. It's the 2 charge one. This is super easy. But when we get to ones where they don't tell us what it is, when they give us the chemical letters and numbers, how am I supposed to know which one they use? So I'm going to show you guys how to do that. So we're on the next part, which is naming them, multivalent metals. Okay? So I've given you this one. It is copper bromide, and so copper has a 1 and bromide has a 2. So what we're going to do is figure out which one is it talking about for copper, because copper has some options for the charges. I don't know which one they use, so now we're going to backtrack and we're going to try to figure out what it is so we can name this guy properly. So step number 1, we have to identify the element. So that's under naming. It's number 1. It says identify the elements. Okay, I'm not answering your question, Katie. Come on, it's cheating. It's way too early. Okay, so we need to identify. So there are 2, copper, bromide. Okay, each bromide ion has a charge of -1, and the metal copper is multivalent, so it could be a +1 or a +2. So we need to be able to identify the charges. Okay, so you guys have a box that's below all this. You guys should be writing it in there. Okay, so your first thing you should have written is CuBr. okay? And then right below it, you're writing the charges. And under copper, you're writing its 2 options, okay? So you're doing the work, as we're doing this stuff, you're doing the work in the box so you can see how you actually do this, okay? So you have copper, Cu, and underneath it, you should have a +1, +2, or in the tiny top of it, like I showed you before. And then bromide, you have Br, and then you should have it as a -1, okay? Now what you do is you reverse the crisscross applesauce. So if you're, because you know crisscross applesauce is what gave those bottom subscript numbers. Now if we undo that, we're going to figure out what was there. So what we're going to do is we're going to pull up the 2 from the Br, and we're going to now make it 2+ for the copper. And we're going to take the 1 from the copper at the bottom subscript, and we're going to move it up, and it's going to be the bromide. So what we just did there by uncrisscrossing them, we now can see what charge was actually there. So when you look at this, we can see, we can start getting some hints from this. So we know that bromide is a -1, and that matches, right? Because when we uncrisscross, it is -1. Now copper could be a 1 or a 2. And when we uncrisscrossed, what is copper showing right now, guys? When we uncrisscrossed, what is it showing copper is? What is its charge when we uncrisscrossed? Yeah, it shows it at a 2. So that's giving us kind of what's going on here, because bromide matches. It's -1 and it's -1. So nothing tricky happened here. It's literally what it should be. So because of that, there's like no reducing and stuff like that. That means that the copper is going to be the 2 charge, not the 1 charge. So yes, Katie, you are correct. So you write the name of the metal first. So this is number 4 for the writing. Write the name of the metal first and the non-metal second. And then you add IDE. Okay, so now this is the next step of naming this. So we've kind of got an idea of the charges. And we're now making sure the metal goes first, the non-metal goes second, and we have to change the name, we have to change the end of the non-metal to IDE. Okay, so we're basically trying to get it from its chemical formula and now writing it into words. So since Cu is +2, it is the +2 charge, not the +1 charge. Roman numerals are used in brackets for the metal. So we saw that earlier when we had copper 2, when we had iron 3, when we had tin 2, whatever it was. You use the Roman numerals and they go in brackets right after the metal. So does anyone want to take a guess with the final answer? What is the name of CuBr2? What is the name of that one? Who wants to try that? And you guys can write this because you can do brackets. You don't have to do subscripts or anything. Who wants to try guessing what the name of this is? The answers are all there. What is it? Do I have anyone typing? What's the answer, guys? Okay, well, that can't be sulfide. Nice try, though, because it's a bromide. Yeah, but where does the 2 go? Where does the 2 go, Jess? It's with the metal, right? Good. So it's going to be copper 2 bromide. Perfect. Good job, guys. So what we did there was we just unraveled everything to try to find the name. So we uncrisscrossed applesauce. When we did that, we noticed that it was a 2 for copper, a 1 for bromide. We double checked everything was okay with what the charges should be, meaning there was no reducing, there was nothing else happening. So then we know that the first one is copper, second one is bromine, which we changed to bromide. And because it is a 2, it becomes copper 2 because it's multivalent. Okay? So that is how you name them. All right, so let's look at this one. So this is on your sheet as well. So I've given you guys these examples. So we're going to look at these 2 and see how we can determine which one they are. Okay? Yeah. I'll just take a drink of water while you're catching up. Let me know when you're done, Belle. Perfect. Okay. So now we're going to look at these 2. So we have Ni2S3. So the reason we're looking at this is because obviously the metals are multivalent, okay? So that's our first clue. So what we're going to do is we're going to do the uncrisscross them, okay? So when we uncrisscross them, that we get, you guys can write this stuff down. When we uncrisscross them, the 3 now goes back to the nickel, and the 2 goes back up to the sulfur, okay? So we have the nickel gets its 3 back, sulfur gets its 2. So when we do that, we have to just do a little double check. Is sulfur technically -2? Yes, it is. So when we look on the periodic table, we see it's -2, we know we're good. So because that matches, we know that that 3 means it's nickel 3 sulfide. We change the end of the name, okay? So that is way simpler. So the last screen showed you in words how you do all that. This shows how it's a little bit easier than what we did because of all the words. Excuse me. So you just uncrisscross applesauce, change it to "ide," and then add in the valence there, multivalencing there. The next one. So we uncrisscross this one. So they both have 1. So when we uncrisscross, they both become +1 and -1. Here's the thing. Is phosphorus -1? I want you guys to look on your periodic table, and I want you to tell me what the charge of phosphorus actually is. Oh, Jess, you're so fast. So fast, yes. It's -3, okay? So this is where we go, something happened. So if it's supposed to be -3, it says -1. What did we do? What did we do there? Yeah, we reduced. So if that was a 3, now it's a 1. That means we divided it by 3, which means we have to do to both. So technically, they were 3s. So they both were iron 3, phosphorus 3. We reduced it by, divided both by 3 to get 1s, to get the final answer. So we have to go back. We have to keep backtracking. So the actual answer is not iron phosphide. It's iron 3 phosphide, because we reduced it to get down to the 1s. So that's the only, I wanted to show you guys that example because all the other ones we've been showing, it's matched. But this one, phosphide isn't 1. You have to always go and check to make sure that charge matches to see if that silly reducing came involved. Okay? All right. So I'm just going to show you guys a couple. I'm going to show you with copper. This is not on your sheet at all. So I'm going to show you with copper how it's just written a little bit differently and how it looks a little bit differently as its chemical formula name. And you guys can just see how it's used that way. Okay. So using copper, we have Cu with a 2 for the chlorine. We have a 1 for the sulfur and nothing there but 2 coppers. So this one is copper 2 chloride because when you uncrisscrossed, the 2 goes up there and we're all good. This one is a 2 because sulfide is a -2, so there was reducing involved there. So this one, when you uncrisscrossed, you look at the value of sulfur, it's a charge, and it's not a 1. So then you realize that's a 2, and this one is a 1. This one is really interesting because copper, it's a 2 for the oxygen, which is perfect, and it's a 1 for the copper, and it just stays the same that way. So that's just an example using copper, how you can see it changes, how you have to look at the charge of the non-metal to know if there was reducing or not. Okay? All right. So the next little part, there are 2 I'm going to get you guys to do on your own. I want you to do these. These are on your sheets. I'm going to give you 2 minutes to do this. I want you to do what we just did there. I want you to uncrisscross applesauce. I want you to double check that the non-metal charge, whatever it says it is that true? If it is, there was no reducing, write the name, have the Roman numeral behind the metal. If you pull up the charges, you uncrisscross, if you pull up the charge and it doesn't match, there was some reducing involved and you need to fix that up a little bit. Okay, so I'll get you guys to do that right now. I'll give you guys a couple minutes. Go. If you notice what I just did, I'm looking at that last question going, that's wrong, that's wrong. Sorry, that should be a PB. It should be a 1, not a 4. That's my bad. Don't worry about it. It's not stressful. It's not like you have to hand this in anyway. So, okay. So, we have uncrisscross. The 3 of oxygen goes up to iron. The 2 of the iron goes to the oxygen. So there's the charges. There's no reducing. We double check oxygen and it is -2, so that's good. So that means it's iron 3 oxide. Okay, perfect. Thanks, Dean. So this one, you probably don't have it unless you saw my mistake ahead of time and fixed it. So this one, we uncrisscross applesauce, and we end up getting the 4 goes with the lead. We get the 1 going with the fluoride. And when we do that, we notice fluoride is correct. It is a -1, so that is lead 4 fluoride. Good. Does a 3 come from the... Yes. Yeah. Yeah. Definitely. So that's how you do the charges of those. Okay? All right. So we are done. So I'm going to tell you kind of what's happening with the plan of life. I have opened up on Moodle a simulation, and what this does is works with you guys to practice what we are just doing, and it's a very interactive thing. So what I would like you guys to do is do this, have a little fun with it, play around with it, and do that until you get comfortable. Try some of the practice questions. Again, you're not handing in the practice, the answer key's given, so do whatever you want to do from that. When you're finished that, you have a couple things that I want you to do. So those are also opened up on, this is one worksheet. It's just 2 pages in the one worksheet. The first page is just single valiant, meaning there's no like copper 2 sulfide or anything like that. So they're just typical ones. You don't have to stress about that. The second page is, they're called multivalent binary ones. So we're joining 2 things together. These ones are the multivalent ones, okay? So just the first page, front page is just regular. The back, they have their multivalent ones, okay? And you can tell they're multivalent if you go to, so first of all, you guys wrote a lot of them down on your sheet, but also when you look on the periodic table and it talks about their charges, the charges are always in the box at the top right. If it or actually no, I can't even say that. I've seen tables that have them everywhere, but they'll have like a 2+ or a 3+. That means it's multivalent. So if you're not sure if it is, look on the periodic table, look for where it says the charges, and if you see more than one, it's multivalent. Okay. No, it's not a matching worksheet. No. No, one of them you're taking the chemical name and writing the words, one you're taking the words and writing the chemical name. Okay. So practice this one, do a little practice there, do the practice worksheets, and then this is the one that you have to hand in. It's one thing handed in, 2 pages on the document. So you have a quiz. I let you know last time, I don't want you memorizing periodic table, but understand how it works, the families, the groups, the noble gases, you know, all that kind of stuff. So it's a little bit different, and what I'm going to do is I'm going to show you how it is different. So, why does it keep scrolling down on me like that? It's just a little bit different. I'm going to open it up for you guys right now. So you need to actually print it off. So it's not an online quiz. Print it off. There's an answer sheet. There's one with the questions and stuff, and there's a sheet where your answers. Just hand that in to me, and you hand it into there. Okay, so what I would suggest doing is doing that right away. We're ending class obviously early. Science is going to be like that, just so you know. And also on days, Tuesday and Thursdays, I have my grade 8s. I teach right after this, so I have to go and prep up for them. So you do have the time to go get this done and then work on the other stuff. Okay. Yeah, so you guys have quiz. Please get that done. You have to print it off. If you can't print it off, then I think you can just write it on a piece of paper and then submit it that way. But guys, try to get it. You guys are really going to need a printer, so you should try to get some access to one that's quite easy, okay? So it says, I think I've lost an electron. In fact, I'm positive. You get it? You lost an electron, now they're positive. Miss Mac, you're so funny. Okay, what's next? Quiz, print off, hand in. No printer, write it out. I already anticipated your question. Do practice worksheet, simulation, and then there's only one thing to hand in the ionic compound assignment, 2 pages in one assignment, due Thursday. Yeah, just hand in the last sheet that has the answers in there for you. Okay? Just wait, I got a couple messages. Yes, Luna, yes you can. Yeah, that'd be great, thank you. Okay, so yeah, Alexis, you'll just have to catch up, so you'll just have to catch up with the work for that, okay? All right, on Thursday, I will not be here, and we're trying to figure out if it will be green screen or not green screen. I'm trying to communicate with the person that's coming in to see if we're gonna do it here. It is easier here because my slideshow is very like mouse clicked. If I did it in Blackboard, I don't know if you guys noticed that, but when you use Blackboard, you can't do the mouse click. It's just literally what's on the screen is what goes on there. So we're trying to figure out what to do. Either way, be prepared for it. I will hopefully try to be able to communicate with you ahead of time if it's in live or not in live, but always be on Blackboard anyway. And yeah, so go take the quiz, do some practice stuff, get your work done. Have an excellent day. Bye, everybody.